Okay, so I have chapter 19. I might have a different problem on listed somewhere, but the problem I originally had an error in it. So I changed it to actually 2A, the one that you actually have assigned, so it's probably a good one to go through. Notice that I've put in the discussion questions, and I've also put in the solutions to the discussion questions here. A great thing to read through and prepare for the multiple choice. Okay, so we're going to go through these. Okay, so we're going to go through 19 to 12. Okay, and so what I want you to do is this one, I want you to fill in right here a 10% markup on cost for profit. Okay, and so we have Pizza Pies Limited has the following value chain. It has boxes designed by a company for 95 cents per box. The pizzas are made in the store and baked for a total cost for $3.80, which includes labor, ingredients, and overhead, so direct material, direct labor, and overhead. The pizza delivery costs $1.35, and they need to reduce the price of pizza to $6.50 to meet local demand. So I wish they would have also put selling price. So put selling price there, and they desire a 10% markup on cost for profit. Okay, so the first thing that I need to do is solve for what is my cost. So if you think about it, the markup's on cost, so cost plus 10% of cost equals selling price. Okay, and my selling price I said is $6.50. Okay, so now I know that cost plus 10% of cost is 1.1 equals $6.50. Okay, so now cost equals $6.50 divided by 1.1, so my cost is $5.91. So I just solve for cost algebraically. In the next problem, this is going to be 10% of selling price instead of cost, and that's why I had you write that in there so you understand this. So basically, I'm going to clear that, and that's just algebra, okay? But sometimes it's hard to know they meant that because you can't have a 10% markup on selling price. So we need to make it for $5.91. Currently, if I add up all these costs, they add up to $6.10, and so I have to cut the cost by 19 cents per pie. And then this gives you some ideas on how they can cut costs, but obviously I need to cut either this cost, or this cost to get it down to $6.10. Okay, so let's go to the next problem, which is quite a long problem, but it's a really good one. Try to make that larger when we do it. And I'm going to go through it rather quickly, so make sure that you kind of pause as we go. And some things are pretty repetitive in this one also. So I would suggest when you do the one on your homework that you might want to use an Excel spreadsheet so you can save some of your numbers, etc. So we're going to calculate the target cost for both Cap and Quinn. So notice that we have direct materials and direct labor. Their selling price for $120. So we have these here. 120, and Quinn sells for $220. Okay, here's my cost for 25,000 units. In addition, fixed overhead is estimated to be $2 million, and variable overhead is equal to $3 per direct labor hour. So the first thing I need to do is figure out how many direct labor hours there are. So I'm going to have to erase these, but make sure you write those on your sheet. So basically, I'm going to put direct labor hours here. Okay, and notice it's $12 an hour, and I have $24 in it, so that one must take 2 hours. $12 for cost and $60, so that one must take 5. So make sure you write these numbers here. I'm going to have to clear them out in a second because my screen doesn't change with them. So I'm going to get my target cost, so let's keep going. They desire a 50% return on sales. So return on sales. So this one is now cost plus 15% of selling price is going to equal my selling price. And my selling price is 120. Okay? So I can take 15% of 120 and get $18. So cost plus $18 equals 120. And so now I can take 120 minus 18 to get 102. So I'm going to clear all that stuff. Okay, so there's my target price there. I figure out my markup, which is 18, subtract it from the cost. For Quinn, it was 220, and it's 15% of 220 is 33, so 220 minus 33 is 187. There's your target cost. There you're done with A. So basically, target cost is simply a market-based approach. And a market-based approach is where I set the selling price. So for instance, let's say I wanted to sell t-shirts. And so how I figure out my selling price for my t-shirts is I go around and I find out what other organizations are selling their t-shirts for. If they're selling their t-shirts for $15, I decide that I want to sell mine for $15 also. And if I want to make $5 on each t-shirt, that means I have to find a t-shirt to buy for $10. The selling price minus the markup. Notice in this one we computed our $18 markup because the markup was given as a percentage. But I want to make $5, so I have to buy those t-shirts for $10. In a manufacturing sense, I would have to make the t-shirts for $10. If I'm not making the t-shirts for $10, then I would have to look for ways to become more efficient, buy cheaper materials, by invest in processes that are more efficient, etc., etc. And basically, if I can't make them for $10, then I don't do it because I can't make my required profit. All right. B, I want the total manufacturing cost. So remember, manufacturing costs are direct materials, direct labor, and overhead. And here I have two overheads. So the first thing I'm going to do is direct materials, direct labor, and my two overheads. So those two together. I have variable and fixed. I want two different lines. So I'm simply going to write 30, 24, 45, and 60 for my materials and labor. And I'm told here that this is $3 per direct labor hour. And I've already written down there that I had 2 and 5 direct labor hours. So 2 times $3 and 5 times $3 is 15. It says, let me make this a little smaller. Oh, you can't read that now, can you? I'll make it bigger again. Okay, so now I have just my fixed factory overhead, which is $2 million, and it says they're allocated on the basis of estimated production in units. So remember the fraction for overhead, estimated overhead divided by your estimated base. And our base is production in units. So I have 25,000 and 15,000. So I have a total of $40,000. So 2 million divided by 40,000 units is $50 per unit. And that's important to, I always put the per there because that's important. If it was per hour, I'd need to take it times 2 and 5, but it's per unit, so I can put 50-50. So right now, I think they're costing 110 and 170. So notice, basically, I'm pretty sure they're costing based on this allocation. Notice this is certain, and I know my overhead is going to go somewhere, but I could have it allocated to here, more than here, etc., etc. All right, so I think it's costing me 110. I need it to cost me 102. I'm not making it. This one's costing 170. I think it's costing 187. So I'm making it on Quinn in this cost allocation. But remember, I'm spreading it between production based on units, and that may or may not be true. Okay, so I think yes on Cap, no on Quinn. So I'm going to, depending on how you worded that, I am in excess of my target cost on Cap. I am not in excess of my target cost on Quinn. So I need to make it for 187, and I'm making it for 170. However, I'm not sure if this is right. So I take part B and I say, or C, I'm sorry, recalculate total manufacturing if the fixed overhead are on the basis of direct labor hours. All right, So basically, notice that 30, 24, 6, 45, 60, 15, those numbers just reappear. And that's why I said it might be easy to do this in Excel, then I can just copy them down. However, my overhead allocation is fixed overhead of $2 million divided by direct labor hours. And I remember you have 2 and 5 written down there. So 2 times 25,000 is 50,000. 5 times 15,000 is 75. So I have 125 hours. That's $16 per hour. But again, this is the cost per unit, so I need to take 16 times 2 and 16 times 5 to get into the Quinn. Now, notice what happens. And remember, our target costs were 102 and 187. So I'm making it for this one, but not making it for Quinn. So this one, based on my overhead allocation, gives me flipped results. So now my question is, which one is right, and are they both wrong? And so the third thing I do is I say, all right, I'm going to break out my overhead. Okay, and this is how I knew my other problem that I originally had was wrong, because they had 2 million here, and they didn't have 2 million there. So if you go to 5B, it's wrong. Okay, these two have to be the same, okay? Now what I'm saying is, I'm going to split up my overhead and have, instead of one base, notice I had applied it all 2 million based on labor hours. Here I applied all 2 million based on units of production. Now I'm going to split up that $2 million and say, okay, 400,000 is based on setups. So I'm going to take 400,000 divided by 500 setups. It's $800 per setup. Okay, 600,000 divided by 300 is 200 per purchase order, etc., etc. So please read through this. You can email me if you have any questions, but pretty much what it's done is I've split up this 2 million. I'm going to allocate it between the two based on what activity drives the cost. So if it's setups, orders, machine hours, etc., etc. All right. So now instead of direct materials, direct labor, variable overhead, and one fixed overhead cost, I'm going to have direct materials, direct labor, variable overhead, same thing as above. So you can 30, 24, 6, 30, 24, 6, 30, 24, 6, okay? Instead of splitting up that 200,000 on one, I'm splitting it up by 1, 2, 3, 4, 5. So I could have down here all 5 of them. They subtotal it up here. So now I have my 800 per setup. So 800 times 100 is going to give me 80,000. 800 times 400 is going to give me 320,000. Some people just do this on ratios. 400,000 times 1 over 500 goes to cap. 400,000 times 4 over 500 goes to Quinn. Okay, I'm going to go through one more, but 2,000 per purchase order times 200 is 400,000. 2,000 per purchase order times 100 for Quinn is 200,000. Okay, so notice that the complication's pretty complicated. Once you had it set up, you could pretty much do it automatically. But now what I've done is I've got my total fixed overhead of 910 and 1.90, which is simply this plus this ought to be 2 million out to the side, because I'm just allocating by splitting them up. But remember, these are on a per unit cost, so I need to divide by the number of units to get the overhead on a per unit cost. And I have 36 and 36. Now this one's 96 and 192. Go back up here. I needed to make this one for 102. I made it. This one, 187, I'm not making it. Okay. And so basically what this one is saying is, if these are truly what is driving the costs, then I should allocate it by this, and this is more reflective of our true costs of Cap and Quinn. Okay? E, look at the proportion of fixed, what proportion of fixed overhead is value added? Okay? So if you think about value added is, what do people pay for? Okay, so if somebody said, hey, I have to set up the machine 5 times to make it, so that's why I'm charging you more, you would say, all right, why don't you automate your machine setups and not have me pay for that? So that's not necessarily value added. purchase orders. And let me make a simpler example. Okay, so let's say that you want to make a birdhouse. Okay, so here's your options. You can go into Home Depot or Menards and buy the wood, cut the wood, assemble the birdhouse, and paint it. And then you have a birdhouse. So here's the question. Would you pay more for a birdhouse that the boards are cut than ones you have to cut the boards? And honestly, for like a kit. And the answer is yes. You would expect to pay more for a kit than you would the raw lumber. Would you pay more for an assembled birdhouse rather than the kit? And the answer is yes, you would pay more for that. And the final thing, would you pay more for a painted birdhouse rather than an unpainted birdhouse? And the answer is yes. So all of those things add value. However, setting up the machine and changing it doesn't add value. So this is why companies have standardized parts. So machine setup, why don't you picture this? Let's say I have a piece of metal, okay, and I'm making, truck beds or parts of a car. And one part of a car needs this wide of a piece of metal, and the next part of the car needs this wide of a piece of metal. So notice this is a wider width than this, okay? So if I have a machine, I might first have to set it, so here's the edge of the machine. Whoops, boy, that's not very good. So here's my edge of my machine, and I first have to set the knife, how about laser cutter, to cut that width, okay? And once this is cut, I'm going to shove this over to the edge of the machine, and I have to cut this width. So notice now I have to move my laser cut because this is a different width than this. Okay. If I could somehow standardize my processes to make sure that the next piece also is the same width, all I have to do is shove it over there and use that same cut instead of having to move that. So that's a setup. Purchase orders. If I get the parts from 50 different companies, I have to have 50 different purchase orders. But if I can somehow make sure there are either less parts, less than 50, I have less purchase orders, or if I can order multiple parts from the same company, I save on my purchase orders. Okay? Machining, though, so basically, I'm not going to pay extra because somebody was inefficient in the design. I'm not going to pay extra because somebody wants to purchase it from 4 or 5 different suppliers. However, I am going to pay to have somebody cut this metal because I don't want to do it myself. Okay, so notice machining and shipping. Inspection is kind of a difficult one for people to visualize as non-value added. The reason it's non-value added is we expect the company to make it right the first time and not add inspection costs to ours. So if we can have processes that are set up so they don't have errors. So for instance, notice if I had to measure every one of these cuts, it might be error prone. But if I have a stop board here and all I do is shove against it, have it cut, shove against it, have it cut, shove against it, have it cut, I have reduced my errors and I don't necessarily have to have an inspection where I measure it 2 or 3 times. And shipping to customers generally adds value. In fact, most of the time we charge the customer for that because the customer likes to have it at their door. So we have machining and shipping. So of all my costs of my $2 million, I can add machining of 5 and shipping of 300. So that's 800,000 divided by 2 million. So 40% of our overhead is value added. Anytime I can eliminate or reduce these non-value added things, such as the little bar to set it against, reducing the number of setups, making our parts standardized, etc., like I talked about before, we're better off. Okay? F. They believe design changes will reduce the number of setups to 25. Fixed overhead costs for setups would remain in change. What impact? Okay? So notice I'm just going to reduce the number of setups. So now I have Quinn to 25 from 400. So this one's changing to 25. And so I do it just like before. I've got 400,000 divided by 125 is 3,200 for setup. But please note that I still have the 400,000. So all I'm doing is shifting it from Quinn to Cap in this particular case. So the numbers are the same exact numbers from above, okay, except for the setup cost. So 80 and 320 above, now it's 320 and 80. So notice all I've done is shift some of the costs over to Cap. This plus this is still 2 million as it was up here. But notice my costs per Quinn and Cap have gone up. I need to find a way to reduce my setup costs. All right, G, as the alternative to design change is a purchase of a new machine that will reduce the number of setups for Cap to 20 and the number of setups to Quinn to 80, okay? So we've got Cap's 20, Quinn is 80. The machine will also reduce fixed setup costs to 200,000. Calculate the manufacturing cost for each product, okay? So notice that I just go through the ones that I've changed. Again, like I said, if you had, notice shipping is the same. I didn't do anything with it. Inspection is the same, 125,000. So I just have these top two, no, the top ones that are different. So I'm just going to redo setup. So setup is 200,000 divided by 20 plus 80 is 2,000 per setup. And then I take 2,000 times 20 to get that, 2,000 times 80 to get that. And notice what I've done. Okay, so the important point here is really reducing the number of setups for one without reducing the overall cost. All you do is shift the cost from one to the other. So hopefully you'll do this on Excel so you can reuse some of your numbers, put some of the ratios in there to get your fractions computed quickly, and hope that helps.